I've got AY over H sine theta equals X, but what's X? X is AY over H. So sine theta is, say 1. 1, thank you. And what's the angle whose sine is 1? Multiple choice. Yeah, 90. All right. That's going to be multiple choice of 90 and 416. But anyway, so 90. Pi over 2. Now, what's happened here? Got rid of the square root. That's the main point of trig substitutions. Get rid of the square roots. And I've got all constant limits. You'd never have found that out unless you changed the limits. And then what about this integrand here? It's a square, but what about it in terms of the y's and the thetas? This thing factors. So my whole integral factors. And that's the nicest situation. So it didn't factor in xy coordinates. You know, in xy coordinates, I could have done this as a difference of squares. But I have ay over h minus x and ay over h plus x, and I'd have still had x and y in both of them. But it wouldn't have worked anyway because I had a variable limit. So anyway, here goes 4. And I can factor out an a over h. And wait, there's another a over h, so that's going to be a squared over h squared. And I've got the integral of y times another y. And I've got another integral of cosine squared theta d theta. 0 to pi over 2 and 0 to h. So, y cubed over 3, say yes?
Yes.
And then I'm going to plug in h. The 0 doesn't give anything, so I'm going to get h cubed over 3 from this one. And we've done this thing about half a dozen times now. We get half of the, when it's cosine squared or sine squared, and these are multiples of pi over 2, 0 times pi over 2, 1 times pi over 2, then you get half the difference of the endpoints. This is going to be 1/2 of pi over 2. And 4, oh, I forgot the a squared over h squared. 4 a squared over h squared. And 2 and 2 cancel with 4. The h squared cancels with the h cubed. And I have here pi times a squared times h over 3. And it works. All right. Now, this will not be the last time that you see me calculate the volume of a cone this semester. But the next time it'll be a lot easier than this. The next time I do it will be in the next section, and I'm going to put the cone back upright. I used to call that dunce cap position, but now I call it sorting hat position. But anyway, we'll use polar coordinates to do a lot of these.